Hey, sixth grade math students, welcome back. Today we're going to talk about the y-intercept. So yesterday, or last time I should say, you did a wonderful job of identifying the slope and being able to figure out the rise over the run in order to figure out what the slope was. Well, that isn't all there is to an equation. We know how to find the slope of the line, but we are missing a piece of the equation. A lot of times we're going to see an equation that looks like this: y equals 3x plus 1. We were looking at it as if, what do we do if y equals 3x? But there's that extra plus there a lot, or sometimes it's a bigger number, sometimes it's a minus number. What is it that that second part does to the equation, to the line? If you remember correctly, when you guys were doing that marble activity, you were able to change a couple of things. You were able to change the number in front of the x, that was the slope, and that would affect how far up and down, whether it was really steep or whether it was straight down or where it was, what the slope looked like. But there was that second part, and when you were playing with the second part, you were able to change something else. So let's look at what that was. So here I have a graph of a line and you can see over here that my line is y equals 3x. So I can tell that that's 3x because it goes over 1 and up 3, or up 3 and over 1, rise over run, rise over run, oops, up 3 and over 1. So it's going up by 3x. But what happens when I change it? What happens if I just added something after that 3x? So in this case, I've added plus 4. So now it's 3x plus 4. What did it do to that line? Well, if you look, the line is still the same steepness. It hasn't changed. These are parallel lines. It still goes up 3 and over 1, up 3 and over 1. So it's still going that same slope. But notice now it's in a different place. I've shifted it. I moved the line up. I moved it up 4 spots. And this is what you were able to do with the marble activity. You were able to change where on this line it would go, higher or lower, higher or lower. In this case, I moved it up 4. And that makes sense, right? Because I added 4 to this. So I still have this 3x line, but now I've added 4, which means I've moved it up 4. And what I've done really is change where it crosses this line. Well, let's look at another example here. What if I do, instead of plus 4, I do minus 6? Again, these lines are all parallel to each other. I've just shifted where they are. This one is now down 1, 2, 3, 4, 5, 6. It's down 6. And that makes sense because this is 3x minus 6. So what have I done by adding this next piece? Well, I've changed where it crosses the y-axis. I've changed where it is when when x equals 0. I've changed where the y-axis is, where it intercepts the y line. And that's really key. That's the part that this second thing does, is it changes. Where is it going to hit that y line? Where is it going to hit when x equals 0? And that's what we practice with the tables. So how do we find this part? How do we identify what it is? Well, it's actually pretty easy because we call this part of the equation the y-intercept. It intersects with the y line. Well, like with slope, I have to give it a spot in my equation, and I'm going to call it, in this case, b. So now I have a formula that actually looks like this. I have y equals mx plus b. So I have y, that's my output. I have m, that's my slope. I have x, that's the number I'm going to put into the equation. And I have b, that's the y-intercept. That's how high or low it's going to be on the graph. And I can use that to identify a equation of a line, because I'm able to identify all of the parts when given the line. So the question is, okay, what's the equation for this line? Well, the equation for this line is I could use it with a table. I could fill out a table and figure it out. Or I can use what I know already to find the equation. So let's start in the same spot. I'm going to start with finding the slope. So I'm going to identify a point. It's easy if you can identify the place where it crosses the y-intercept. And then I'm going to identify another point to the right of it. And then I'm going to look for the rise over run. Well, in this case, it's going to go over 1, 2, 3, and then it's going to go up 1, 2, 3, 4, 5, 6. So it's going to go over 3, and it's going to go up 6. So it's going to go up 6. Over 3, up 6. So the rise over run is, the slope is 6 over 3. Well, 6 over 3, that's really 6 divided by 3. That's really 2 over 1, and that's really just 2. And that makes sense. It goes up 2 over 1, up 2 over 1, up 2 over 1. And if I go that many spaces, I get 3 and 6. All right, let's look for it now. Okay, so now I've got y equals 2x plus b because I have this 2. 2 goes in the spot for m. But what is the b part? Well, the b part is the y-intercept. So what I'm going to look for is the place where this line crosses the y-axis. And where does it cross the y-axis? It crosses it when y equals 4. So I'm just going to look for the place where it crosses the y-axis. And that spot is 4. That's pretty cool. So now I have, this is my equation. Y equals 2x plus 4. Because 2 is my slope, 2 is my slope, 4 is the place where it crosses the y-axis, goes up 1, 2, 3, 4, so my line moves up plus 4. And that is how we can find very, very quickly an equation for a line. In fact, I can find an equation for a line even faster than I can for a table. You show me a line, it's linear, I can go boop, up, rise over run, done, y-axis, done, there's your equation. And the more you practice it, the better you're going to get at that skill. So let's practice it a couple more times. Here's another line. This line is still going to follow the form y equals mx plus b. I'm looking for the rise over run. I'm looking for b as the y-intercept. So given a point, I'm going to find the y where it crosses the y-axis. I'm going to find that y-intercept, 0, minus 7, because it's way down here at minus 7. And then I'm going to find a point to the right, and I'm going to just count how far over. In this case, it's 5. How far up? In this case, it's 4, so it's going to be 4 over 5. So my slope is 4 over 5. And b is minus 7. How do I know it's minus 7? Because where does it cross this line? Where do my two lines meet? Here's my y-axis, 1, 2, 3, 4, 5, 6, 7 right here. Notice it's not this one over here. You got to be really careful about, some people will like to find the x-intercept. That's not what we're looking for. We're looking for where does it cross the y-axis, the up and down. So in this case, it's minus 7. Since I'm going down 7, my answer here is negative 7. So when I put it together, I'm going to get y equals 4/5 x minus 7. Because of this minus here, just translates into a minus here. 4/5 is my slope, minus 7, minus 7. All right, another example. Aha, this one is going down, so I know something about the slope. I know that the slope is going in the other direction. So I know my slope is going to be a negative because the rise over run is going to go down. But let's look. Okay, so I'm going to find a spot. I'm going to find the y-intercept. I'm going to find a point to the right of it over here. I'm going to look at how far over does it go. It goes over 4. And I'm going to look at how far down it goes. It goes down 6. So it goes negative 6 for its rise because it's going up negative 6, which means it's really going down. What's my y-intercept? Well, I'm just going to see where does it cross this line. Not this line up here. So it goes 1, 2, 3, 4, 5, 6, 7, 8. And I know that because I already found this point, 0, 8. So 8 is my y-intercept. So there's my slope, negative 6 over 4. I can reduce that to negative 3 over 2. And then my y-intercept is 8. And I get y equals negative 3 over 2x plus 8. Again, this is really easy once you get used to it. It does take a little bit of practice, but once you practice it and once it kind of sticks in your head, it can happen really, really fast. So for today's work, I want you to practice this skill. Good luck.